We give everybody a few minutes to log in. I apologize for the interruption and delay. Um, it was really, I don't know, something crazy. There's a lot of settings to know about doing YouTube and the lives, and just there's so much to figure out and understand. And anyway, one wrong button, and it causes the whole stinking thing to just freak out on you. And yeah, anyway, I had to basically cancel the other one that I had posted and just basically start from scratch here at the last minute. Anyway, I apologize for that. Um, yeah, I appreciate that, guys. Yeah, I see in the comments coming through. Like I said, we'll give everybody a couple of minutes. And I've got a list of things. It's just something I've thought about doing for some time now. I hope the quality is coming through okay. This is my yard. And we recently moved into this new house, and we're still kind of getting the internet and things figured out. Anyway, let me know if the quality is coming through okay on your end. I've kind of got things pulled up here on a separate screen, and anyway, I'm testing a bunch of stuff. I would like to do more routine live streams. It's something I've talked to my wife about pretty heavily. It's not sure when I'll actually 100% commit to it just yet, but we'll get there. Um, anyway, uh, one of the yeah, we'll go ahead and get rolling here. One of the major or the last live stream I did, which was right at about a month ago, it was actually a service call that I was trying to finish up with. I'd been there the entire day. So that was the one that we did the flow sensor, and we also replaced some of the entering and leaving water sensors route of calibration, and that was after we had already made a bunch of other uh, adjustments throughout the whole day prior to that. So that actually turned out really, really well. That building has been performing exceptionally well since then. Actually, they hadn't really had it work as well as it is now in quite some, or really as long as that engineer has been at that property, he's not had the building maintain as well as it has now. So, and really, what that came down to was uh, how the building was being controlled on the discharge air side. Like I mean, like I said, I talked about it in that live stream video and stuff. I mean, they were running like a 60-65 degree supply airs on some of those air handlers, and it was all still pneumatically controlled. On top of that, some of those pneumatics needed a little bit of calibration. So anyway, that property has done exceptionally well. The chillers performed really well since we left there last. They've started taking steps and measures to really improve the uh, really improve on how the sorry uh, how well those coils performed over time and long term. So in not getting as dirty as they have been as fast. Now, KC asks, how many employees do I have? Currently, we are running a little over 50, I think, or right at 60 something. That includes, the company I work for, so I oversee our entire HVAC division. Inside of that division, I've got three departments with supervisors. I have a service department, a projects, and a PM, right? We make up about half of the total team. So we're a little over, right at or just over 30 technicians and supervisors, including myself at that point. And then we have our admin staff. And then we also have an automation side that's separate from our like HVAC service side. We have our automation team as well. So grand total, that's about where we're at. So I think it's 50 or 60 something employees total. And we are still trying to expand. Even at that, we have a hard time keeping up. Anyway, I'm not going to kill a bunch of time on that. So like I said, the CGAM went really well. I got a huge response. Everybody really enjoyed that and doing that live feed. Now, something I do want to update from that feed was um, this flow sensor, is electronic flow sensor. It technically, I I do need to go back and make an adjustment to it. So those electronic flows have like a little heated diode in them, and they have to be put in a certain way with the direction of the flow. And I've had a couple of emails come through from you guys, and I really appreciate that. I'm not an expert in everything. I try to just do my best with what I do know and what I can learn, and I can't remember everything. And something I was struggling to remember at the time was exactly what the orientation was supposed to be of that sensor whenever I was installing it. And I actually ended up putting it in, it's technically backwards. So somebody had sent me some documentation that showed that that sensor dot was supposed to face the incoming water stream, not face away from it, but face into it. And I faced it away from it. So what can happen? It's not extremely detriment, but what can happen is uh, that sensor senses flow by how well that diode is able to be cooled by the flow of the water stream, and if that water doesn't flow across it properly, it'll still register flow, but over time it'll cause a premature failure. Versus if you put it in the correct way, you'll get a lot more life out of that flow sensor than the way I put it in. So anyway, I do need to go back and make that adjustment. I do appreciate that email. I got a couple of them, so always open to that kind of input. The little bitty baby cooling towers. That was a pretty fun one. Really enjoyed that. A lot of people, very few people really get to see those. We have a couple of them that we service. I can't tell you the customers, but they're just different. End of the day, they work like a regular cooling tower. There's a lot of questions as, okay, what were those towers servicing? So they were running the condenser water for 5 like 2 and 3 ton water source heat pumps that was servicing a commercial building. And that's all they were. Nothing fancy. That's all they needed for those handful of heat pumps. They have gone other directions with it? Oh, sure. I mean, they could have went traditional route with split systems. Why they went that route to begin with, I don't know. We weren't the contractor that originally set that up, but they really weren't happy with the people that did do it. And so we got brought in, and we've helped them work through a lot of issues that they've had since that equipment got put in. Now, I will provide an update, and it was kind of funny. One of my technicians, y'all know Curtis, right? So Curtis had been working on those towers a couple of different times in the past, and a comment that several people had was, I needed to have an equalizer installed. And sometimes you kind of you get that zoned in fog brain, and you're really not paying close enough attention. And Curtis, after the video, me and him were talking a couple of days later, and he's like, "Dude, you realize there's an equalizer there, right?" And I said, "What do you mean? I didn't see an equalizer." And he told me the drain line, so that I was using, that had it had 3 valves. I had a valve at each tower basin, and then it had a separate valve specifically for the drain itself, and that's what I was using to dump some of the excess water as I was trying to balance those 2 towers. He told me that is the equalizer line. Now, that equalizer has a drain on it to where the towers can be drained through that line, but that is actually the line to use for equalization. I was there for two days back to back, and I completely missed that. So anyway, went back, got those valves open back up so that it will equalize. They haven't had any of those significant issues since then. I need to check in with them to see if they've actually cut back all that foliage yet. But they haven't called in, reported any major significant problems. The overflowing, I mean, it had literally turned into a little mini swamp back there. It was pretty bad. But yeah, that was a pretty fun call, some fun repairs. One of the goals I have is I really like to share the really unique things that not very many people get to see on a regular basis. And that was definitely one of those. Not many people get to work on those little small towers like that. They're not that common in our area, especially. So, anyway, just something I enjoy doing. Let me look at a couple of comments here. Switching to supermarket, refrigeration chillers. How easy is it to transition? You think it will be? So, I've actually had a couple of people asked that recently, wanting to look at maybe go from supermarket refrigeration over to like the chiller side. Honestly, there's quite a bit in terms of controls and things that really goes into supermarket type systems, and those big racks. They are very different. End of the day, they are truly truly different. But the one of the big things that gets in people's ways is with chillers, they struggle to understand the complexity of the system, which chillers, while they're truly very simple, the controls of them are quite complex most of the time whenever you really have to do a deep dive. The physical operation of the principles that they function off of are really, really basic. Like, a lot of people think chillers are way more complicated than they are. Where people get in trouble is the sequence of operation and the controls of them. They've got a ton of safeties built into them. So my point behind that is you're very familiar with that level of work already doing supermarket refrigeration, right? Those large rack systems, you have a ton of controls. You're dealing with equipment that is, tens of thousands of dollars most of the time, especially in repairs. I mean, you're used to dealing with that level of work and equipment. With a chiller, it one simple mistake sometimes. I mean, that could cost you 10, 20 grand on a smaller equipment. You start talking centrifugals, you make some of those same mistakes on centrifugal type equipment, that could be an $80,000 mistake, right? Now, I don't personally know the exact numbers when it comes to supermarket side, but I know enough about it to know that you could have some similar situations to where you make some just simple, honest mistakes. Sometimes it could lead to very expensive mistakes. You're used to that type of work already. I would say that if you could do that, you would do really well with things like chillers, centrifugal or air cooled, however you go with it. And I would definitely encourage you to look at it. It's an extremely rewarding side of the industry. Now, something I'll throw in with that is everybody sees being able to do chiller overhauls as like the end all be all mecca of being a chiller or HVAC technician, mechanic, whatever you want to call it. And I want to caution that line of thinking, okay? The reason I say that, and I've actually had some comments recently, I've gotten some emails from some guys as well, kind of expressing this, is while it is a ton of fun and doing an overhaul and a teardown is an extremely unique experience that only a very small portion of the technicians in our industry actually get to participate in. And it is well worth knowing how to do that and having that knowledge. Extremely worth it. And having that also makes you extremely valuable to companies because so few people can. But take the experience and the advice of some people that have also walked down that road. Be cautious to base your career around only specializing in that and letting that be the only thing that you really hone in on. The reason being is there's only so many times you can do that before it just starts to become very monotonous. And one huge benefit we have in the HVAC trade is we get to see so much diversity, especially in the heavy commercial side, like what I do, or the industrial side. There's just so much diversity in what we see. We literally go from a mini split to a centrifugal to a RTU to an outside area. I mean, there's just so much we get to do and work on. And I've intentionally not allowed my career to just strictly hone in on commercial chillers because of just enjoying the diversity of it. Be cautious trying to become the world's best overhaul technician unless that's just you're very a monotonous type of person, it's going to get old quick. And there's plenty of stories out there. If you dig long enough, you'll see them in my comments where they talk about the fact that it can get old. Anyway, I'm going to move on from that. I did have a question from Blake. Am I union? I am not. I've never served in a union. There are unions in Texas, but they're not. They don't have a big presence. Most of the unions here do extremely well on the new construction side. For example, downtown Austin, all the major high rises that get built almost always get built by union-based companies. Within a couple of years, maybe 3-4 years down the road, after ownership and different things change and shift hands, and they get the unions no longer control those buildings. Very rarely do they keep those buildings. Most of the time, they end up getting passed off to non-union-based companies like the one that I work for. So the private sector does extremely well in Texas, honestly. Easy heat cooling, Super York. Yeah, Super York. Yeah, that's funny. Instead of Super Tech, that was a really funny one. Anyone take a part of machine, take more knowledge, troubleshoot. Yeah, I like Mino. I hope I pronounced that correctly. Yes, anyone can take it apart to troubleshoot. So to kind of close that thought earlier, troubleshooting is my personal preference when it comes to chillers. I love to troubleshoot them. Overhauls are a ton of fun. It's a very unique experience. I don't try to make it my full-time gig, but he is correct. Troubleshooting them is where it's at. Okay, moving on. The Aeon. Yeah, so that Aeon that I worked on the other day had the exhaust fans down. I did the video on. That's something I find really common, and it's actually kind of a niche. So something I teach my guys is look for the niches in the industry that very few people know much about, especially even within your own company. Whoever you're working for, if you see that there's a specific area that not very many people know much about, and you'll constantly, like say a service call comes in for it and they really don't know who to send, that is the area that you need to become the master at, because that's one of the ways that I really built my career, especially as quickly as I did, was I looked for those areas that nobody else could really master or knew much about, and I honed in on that, and I studied, I researched, and I really focused on that topic, that thing, and that really propelled me through my career, because I became the guy wherever I went that could work on the things that very few other guys could. And I say it to say outside air systems is a definite area that I see a lot of lack in the industry as a whole. Not very many people, one, know much about or able to commission properly. I see all kinds of issues with them routinely. I've done a couple of videos recently talking about outside air systems. And again, I'm going to stress here, they're not comfort cooling. They're outside air. They're not meant to process that air down to make you feel comfortable, as in we're not shooting for 55 degrees here. We just want to make that air tempered so that we're not, in my area, for example, we're not pushing 100 degrees of supply air into the space, putting a lot of extra load on the comfort cooling systems. Now we want to get that down to, 65, 70 degrees. Anyway, that is a major area to focus in on, but there's several that I've had that really I've had to go through and completely recommission, and this being one of them. And one of the major comments and questions I got on that, and you'll see several comment threads in that video's chain talking about the compressor cycling. So there were a lot of questions about those compressors constantly cycling and the sound of the cycling. What you are hearing is, so the first and second stage compressors are unloading compressors. So they have unloaders built into them. On this particular series, they're internal unloaders. So there's two main types for scroll compressors. You have an external and internal unloading. You always know which is which when you walk up to it. An external unloading scroll will have like a little, it may be like an 1/8 inch or 1/4 inch piece of copper sticking out the top of the scroll head, and it'll go to like a little solenoid valve, and then that'll dump over into like the suction line typically. And when that valve activates and it opens the solenoid, that is unloading and is not completely making the compressor not compress anymore. So, for example, if it's a 10-ton compressor, it may go from doing 10 tons of refrigerant being moved to say like 5 or 6 tons worth of refrigerant being moved. So we've reduced the amount of capacity that compressor is able to move through the system by opening that unloader. The internal unloaders do it a little differently. They actually have a valve that opens internal on the scroll plate, and to where only part of the scroll plate is actually processing refrigerant and the other part's not. Similar to how like a screw compressor works, which if you don't know what that is, that doesn't really mean much to you. But anyway, an internal unloading compressor is you'll have the main plug for the power, and then there'll be a second plug somewhere, usually towards the back end of the compressor from the power plugs, where it'll have like 2 wires coming out. Usually they're like 2 blue wires in a separate plug. That is the coil terminals for the unloader internally. So anyway, that system is trying to maintain a very specific parameter of supply air. So it wanted to maintain 70 degrees with what was it? Something like 55% humidity, I believe. And what it's doing is it's going to cycle those compressors to try to maintain a specific coil temperature and that's those discharge air parameters. Now it also uses hot gas reheat, which is another complexity of that system and outside air units have. Regardless, it's using both, but as it overshoots those set points, it will unload the compressor. Instead of turning it completely off, it just unloads it so that it's not putting as much stress on the compressor, and it's easier to get a much finer controls, right? So instead of going from 10 tons to 0 to 10 tons to 0 tons on that compressor, you're cutting it back by, let's say, 50%. I'm just throwing a number out there, but instead of going from 10 to 0, you're going 10 to 5, 5 to 10, 10 to 5. So you're controlling a much more minimal amount between fully loaded and not, to really hone in that discharge air temperature that you're looking for. So anyway, that was what was happening when those compressors were cycling, and it sounds really rough. I mean, it does. It does put stress on that compressor, but it's a lot less stress than turning it completely off. And that is also where you lose almost all of your efficiency is short cycling circuits. At startup, going from lock rotor amps to full speed that is a huge. I mean, the inrush current is massive trying to accomplish that, even on a small system. And that is how the industry is improving in its efficiency numbers right now. It's getting away from just a stop-start compressor and moving to a modulated speed specifically, or being able to load and unload, something along those lines, for the simple fact of we're trying to reduce the number of times we turn off and on and get more dialed into a specific demand condition. That's where the efficiency comes in, which we taught. I mean, if you ever go through like a system design class, I mean, they talk about that in that class. Is your goal is to make the system sized appropriately so it turns off and on at a less, right? So if it's oversized, it's going to short cycle like crazy most of the time. So if you size it properly, it will only have to turn off and on every couple hours, if that. That's a system that's going to run more efficiently. Anyway, I get off on tangents. So regardless, that was the cycling that you were constantly hearing during that. So I just kind of wanted to point that out and kind of answer that question so that everybody knew what that was. Moving along here. Sorry, I'm trying to keep up with some of the comments that I saw. All right, I'll go ahead and talk about it now. I do see a comment about the two training videos I just posted this weekend. So I did one yesterday and then one today. I do a monthly in-house training for our technicians and our customers. They are able to join either live, or our technicians can join in person, or they can join remotely, and the customers can join remote as well. I was trying to find a little bit easier method that was less invasive on trying to film that so that we can film the class and then post it later so that everybody can review and enjoy. The way we did it this last month for September, which are the two classes I posted this weekend, did not really turn out as well. And I debated posting them, yes. Now, I chose to go ahead and put them out there for the simple fact of I know they're hard to follow due to the camera quality was extremely poor, did not turn out the way I expected, and the audio was just as bad. I actually had a mic running when I did that audio, but the way that the program recorded it, I have no idea why it did it the way it did, but it was just absolutely terrible. I'm not going to be doing that again for the month of October's trainings. Something else that I'm also going to make a change on is usually in the past, I've tried to edit those trainings down to make them more appealing to watch. I just don't have the time to continue doing that. I mean, most of them are an hour and a half, 2 hour long trainings. So you're going to start seeing those trainings getting posted as more just raw footage. I might kind of take some of the ending and beginning off of them a little bit and do that much. But what you saw was almost 100% raw footage on both of those classes. And that's going to be easier for me to manage and still get those out there. Now, I specifically post those classes for our own technicians to benefit from, but y'all get to benefit yourselves in the fact of they're open on the channel. Anybody can review them and watch them, but they are specifically tailored to our technicians so that, they get the most benefit out of it. Anyway, point is, I'm sorry for the quality issues and things. We're going to make adjustments to where that's not like that, but I didn't want to not give you the chance to benefit from it at all and just never getting to see it. At least this way, if you're able to make it through the audio and the quality of it, you get some form of benefit out of it. I appreciate the patience on that. And the feedback is also helpful. Just trying to make sure that I do the best I can. Any recommendations for a California technician or chiller company on a desert area? Honestly, not really. Great channel. Appreciate that. Watching from UK. Yeah, it's actually surprising how many people like globally watch this. I never planned. Well, I'm sure every YouTuber probably says this to some degree. I never truly expected this to really do much, but anyway, let's move on some of these calls. Found the other outside air units where they had the Daikin outside air. I've actually got some updates on that. So in that video that I did, I talk about the building static pressure not looking right and needing to go back and look deeper into that later. I did. And it's honestly, it's kind of sad in a lot of ways what the reality of why that issue was happening the way it was. But I'm going to try if I can. I'm not going to promise it, but I'm going to try to do a separate video and really go into depth and explain what happened there and why, but it all goes back to the original install. And I'm not going to try to call anybody out in this, but people were just being blatantly dishonest. And that's the only way I know to really put it. What I found was the return air fire damper that ran 3/4 of the building was screwed shut by accident by the installers. And even when the fire technicians went and installed their fire equipment after the fact, they knew, they knew that it wasn't opening properly and you couldn't rotate it. They chose to ignore it. They installed their equipment anyway, knowing that something was wrong. And then after that, the air and balance company, the test and balance company that came back, I've got their reports. They were very specific in their readings that they found. And they stated that all the return air grills that were after that damper were moving appropriate CFM. They specifically have the CFM, the balancing, everything written down. And I'm sorry, but the whole thing was not accurate at all. That damper has been like that from startup, period. Like, that's not something that just happened. No, they accidentally ran a screw through a linkage. They didn't realize it when they installed it because they just didn't know any better. And everybody else just ignored it after the fact. And that building has never had this system operate properly, period. And this is why. This is exactly why. So the customer is actually having to tear out part of their wall so that we can get to the chase properly to try to fix this. And that's something I'm going to be doing this next week. Again, I'll try to shoot a video on this and try to capture some of this and explain in more detail then. But and show the results of it. That way you can see what it turns out at. But it was yeah, no, it's rough. It's tough for the customer because now they I don't know how they're going to work this out with the construction company, but this is thousands of dollars in damages that's going to be required to try to fix this to make it work properly. And so anyway, yeah, it's I hate those kind of situations. I hate to see it. Regardless, the York sensors. So the York air-cooled chiller that I went and did the sensors on is pretty straightforward from the video. They've not had any issues since then. I did have some comments that everybody said, well, why not just go ahead and change both sensors? I could have. It's not a standard practice that I've made. I try to just fix what's absolutely required. Most of our customers don't want the above and beyond a lot of the time. Now, more of the process cooling, industrial based, yes, 100%. But when you start talking commercial real estate, their main focus and goal is to make this as cheap as possible all the time, no matter what. So it's not my standard procedure to do that. So that's not what I did. Definitely a solid option for sure. But something I just want to kind of reiterate, if you're ever in that scenario on that type of equipment, that equipment judges all of its operations based off of that leaving water sensor. The entering water really has very minimal impact on the total system logics and how it's written inside of the logic of the controls from the factory. So that's a really easy solution if you're in that scenario where they really need to get back online, just swapping those sensors. So I just really encourage little things like that, or things you kind of pick up and learn along the way, or that's anyway. that has turned out really well though. We got the sensor replaced. I think I did something on that. Maybe I did a shorts video or something. I don't remember now. I did something to kind of show going back and taking care of it. The overhaul. The overhaul turned out perfect. Honestly, that chiller actually runs better now after we did the overhaul than before the overhaul. So I think we probably resolved some issues along the way. We were just kind of trying to fight through. Now, a problem that building has is it doesn't have a very good flow balance, and they've had a lot of remodels and stuff going on, and they've had a lot of things happening on that building, and a lot of hands and construction messing with it. So anyway, that whole loop needs some attention, but it's doing extremely well. They actually the RTHD that's beside it, which is it's a water cooled screw chiller by Train RTHD, and look up the manuals on it. But it actually went down for something happened with the controls. I had one of my technicians go look at it, and he got it resolved, but it was down for like 2 days, and they were able to kick on that CVHF, got it online, took care of the building, did a really good job. They had an issue with the automation controlling the condenser fan or the tower fans properly. But once they took care of that and got the water temps back down, did extremely, extremely well. And that was a very fun journey. It was a good experience. The technicians did a great job. There was a lot of just issues along the way in general for that job, but we adapted, overcame, did what we needed to get everything straight and back online. So very happy with how that turned out. Let me check the comments here. Taran M. I'm horrible at names, so forgive me. But regardless, that's a big part of what this channel is for. All right, there's not enough people that have taken enough time to really help grow and build others, and most of what I've had to learn on my own. There was nobody there to coach and guide and to share those experiences. So I want to do that. I want to provide that opportunity for those who've not gotten that kind of opportunity. But the other thing is I want to really show people who aren't in this side of the trade how much is here and how much there is to offer. People who are trying to decide, is HVAC the right trade for me? Well, here's things you could be doing yourself. Like there's nothing that I work on or there's nothing that I've done that every single person in this industry could not achieve to some level and could not have as their daily basis either. So I want this to be an encouragement to all of those that this is the kind of career you could have. This is how great it could be. You just got to put some work in to get there and to achieve it. So I appreciate the acknowledgement on that, because it's a big part of the heart of why I'm doing this to begin with. And if you've never done something like this and try to create an audience like this, it's not easy. And there's a lot of people that would try to see you fail along the way, to be honest. Do I work on absorption chillers? The answer is no. We don't have any. We just don't have any. I know of absorption chillers. I've done a lot of research on them. I have a understanding of them, and you're using refrigerant pumps and water, and you don't have like an actual mechanical compressor that's running the system. You're using just thermodynamics and refrigerant characteristics to create pressure drop and still achieve the same cooling effect. And but it's not the same thing as like a centrifugal chiller where we've got an actual impeller on the compressor that's moving the refrigerant in the system. It's all done via like just physics. Honestly, it's a physics chiller, if you will. So they're really interesting. I don't have any. I've never worked on them. I don't know that I will. I just don't think we have any given where we're at. Explanation. Electric drives not completely. What I do. I have a York chiller, YVAA, expansion, electric valve. Okay. A problem that a lot of people have, is on York chillers, especially. I once they get to a certain age, their EXVs tend to start to stick up. Engineering Mindset created a very good video explaining EXV operations, and I highly recommend y'all go check that out. But basically, those valves have a thread, and they've got a thread gear in there that has to slide in and out, and it's got a couple of not truly armatures, but just they've got some gears in there. Sometimes those gears begin to get bound up, or they don't slide properly, and the worse it gets, the louder that those valves will get. So for you, HH is the commenter. For your specific scenario, one of the tests that I do is I put the machine into a test mode, and or into service mode, and I run those EXVs all the way open and close, and basically do like a calibration on them. And what I'm checking for is, one, do they move properly? But two, how do they sound? Because most of the time you can tell by the sound of the valve while it's actuating what condition those gears are in. The louder that valve gets, the worse condition it is. And specifically, what you're really looking for is that travel space, right? So the first thing that valve's going to do is try to bottom out all the way. So if it's already bottomed out, you're going to hear it ticking and those gears skipping while it's bottomed out already. Once it finishes that cycle and it goes to open, it's that opening cycle that you're really paying the most attention to. Those valves should be almost silent most of the time. They may have just a slight bit of noise upon that travel in between full open and full close. If you hear that valve making a lot of ticking and grinding, like significant, during that travel space, those gears are having trouble, and that is not a good thing. If you don't know how to put your equipment into service mode, you could always do like a power cycle, or just cycle the equipment would be an alternative. I'm not going to explain how to put chillers like that into service modes, to be honest. There's so many things you can do to tear these things up and make extremely critical damages. I'm not going to set somebody up for failure that just doesn't have enough training on something like that. But if you cycle the equipment, it'll automatically put itself through a valve calibration, and you can listen and feel for the valve during that calibration time frame. So that would be an alternative. Can I turn chiller while in service? You can run different components on a YVAA. I don't recommend. I don't know that you even can. I've never tried. I don't believe you can turn it on while in service mode, but even if you could, I wouldn't. There's so many variables in those things, and trying to control those Raptor drives, you cannot. You are not physically capable through that interface to control that chiller fast enough to modulate all the things you have to, because you have VFD driven condenser fans, on top of the fact that you've got to control that Raptor drive and the speed of that compressor, on top of the fact you have a economizer valve and a feed valve feeding, or the liquid drain valve, as YVAA states, feeding the flash tank. Or if you have a YCIV, you've got a feed valve and a drain. But there's way too many parameters to have to do at the exact same moment. Don't try to run it. Don't even attempt to run it in service mode manually. let the machine run itself, only go into service mode so that you can control a specific component, such as cycling the condenser fans or cycling the valves specifically. Anyway, so those valves are common failure points. And one of the most common things that I'll see is when I start having superheat issues, either too low of a superheat, too high of a superheat, either way you go with it, one of the first things I do is I go straight to those valves and I do a calibration test and I see how they sound and how well they actuate. And you can look through the sight glass and you can see that armature moving in and out during that time frame. That is a very critical test to try to do. And it's not something that I see very many technicians that I've worked with over time has really ever done it that way. But it works extremely well for me. I've diagnosed a lot of bad valves and, a lot of nuisance alarms. I mean, it'll trip this time and then it won't trip for another week or 2 weeks. Well, it's because the valve is in the early stages of sticking and failing. It's bad enough you can hear it. You can hear by the sound. It's bad enough to know what the problem is at that point, but it may not show the signs and trip the alarms until then, because the chiller doesn't know the position that valve is in. It has no reference point. So it may think that it's at 20% open, but because the gears are sticking in there, it's not actuating properly. Heck, that valve may be at 50%, but it thinks it's at 20. And so by the time it gets down to what's supposed to be 0, because maybe it's overfeeding, so it wants to close down to get the overfeed under control, to get to lower the superheat, it can't continue to close like it needs to because it doesn't know that it's in the wrong position. And the interface may tell you, oh, your feed valve's in, 0% or 5% position, when in reality, if you could see it through the sight glass, it may still be at 30%. Again, that goes back to how that happens. And it may be just every 20 cycles it has, it may get out of calibration by 1% per cycle. But over enough cycles, over enough runtime, that's able to build up enough to where it gets way out of calibration. And that's when your nuisance alarms start to trip and trigger. Same thing can happen with trains, carriers, that they can all do the same thing. None of them have a valve position reference point. At least none of them that I'm aware of. I'm sure there are some, but anyway, that is what you really want to hone in on. HH is you really want to see how that valve is actuating. Yes, Super York. That makes me chuckle every time. I'll be honest. Programming a VFD. There is a lot to talk about. Really, the basic level when it comes to VFD programming is it really depends on the application. The vast majority of the time, they're going to be some form of fan control, and the vast majority of the time, they're going to be running off of a automation system, right? For the sake of not making it confusing, I won't discuss the rest right now. But what's most critical is going to be making sure the motor parameters are programmed properly, from the amps, the hertz, the volts, the speed, and even something as simple as there are motors that I get. One may say 460 volts. One may say 480 volts. Don't even something as nuanced as that. Make sure that drive is programmed properly. If your tag says 480 on the voltage, and your drive says 460, programmed from the factory, don't just assume that it's okay. No, that will over time cause little nuanced things, and that VFD is extremely fine-tuned and calibrated to run very specific ways. And if you don't have it set just right, it's not going to run exactly like you want it to. Anyway, parameters. The parameters of the motor is one of the most common areas that I see improperly programmed, because they just didn't take the time to go through and very specifically do each and every parameter in there. It's there for a reason. You need to make sure that it's accurate to that motor. Let's see. The other major thing that really gets into it when it comes to doing parameters is how it's being controlled and understanding the different types of controls. I've done several videos, or I've actually got a full training on VFDs and the programming of them and how to set them up. I went into pretty good detail in that video, so I highly recommend you go check it out. But knowing what kind of control signal you're getting is really critical to know how to program your analog input to know for the drive to know what it needs to do. If you're going to go as far as, and if you want to know more about like a standalone drive that's trying to look at its own static pressure or something along those lines, and you're trying to program a PID or a PID loop into that drive, that tends to be a pretty complex process, and that's not one I'm going to try to explain now, because even myself, I could do it if I'm in front of it. I've done it a number of times, but trying to go into detail and explain it on the fly, I'm not going to do it justice. It's not. It can be tricky. It can be really, really tricky to try to get that tuned in just right. Anyway, yeah, it is good to have your drives slightly oversized, but it really kind of depends. Something else I'm going to actually talk about now, something I've been thinking about, is y'all really, as a technician, you need to get up to speed on how variable speed systems operate with the inverters and everything, because it won't be a tremendous amount of more time. It won't be about a very few number of years in the future, and almost everything's going to be at this point, right? So as we continue to grow in efficiency and system operations and a lot of things, this is the new standard that's here for the industry to stay. And one reason why I really push this too is this. So in the United States, we have everything is 60 hertz. This concept that motors can only run at 60 hertz, you need to start getting away from that mindset, because we're going to start having motors that run 80 something hertz, 100 hertz, 200 hertz. We're already seeing it in the trade, and we've even got equipment. We just picked up a new account that has new equipment that's really struggled to operate since install, and what we found was they programmed the drive wrong from the factory, and it says on the factory data tag, this is a Train air handler, brand new. It wants the system programmed to run 88 hertz on that motor. The motor that's in there from the factory is a 60 hertz motor, but the factory wants to operate it at 88 hertz. And part of the problem they were having was when they commissioned the system, they commissioned it at 60 hertz, and it ended up killing the motor, and they were having all kinds of static issues along the way. It was because of how they got logged in at this notion that everything has to be 60 hertz. That's not true. And we've got on the chiller side, we see it all the time right now. York screw compressors, they run 200 hertz. That's their normal. And so you really want to get ahead of this curve, because the curve's already here. All right, understand that it's already here. It's not coming, it's here. VRV systems, mini split systems, a lot of your advanced, regular split systems that like American Standard and them are trying to do, where they're trying to get more efficient and compete and things. I mean, even as far as like Aon systems. I mean, Aon has VFD driven compressors, scroll compressors that are on VFDs now. I mean, this is where the industry is. You need to catch up, and now's the time. Don't wait any longer, because this is going to leave you behind more than it already has if you don't already know about this. Just please take the time. This is going to only benefit you and it will hurt you if you don't do it now. I'll get off of that soapbox. That Carrier RTU that had the refrigerant issues, we ended up replacing the refrigerant in. It's still doing wonderful. We have not had any more complaints, any more issues out of it. Customer is extremely happy with the results. I do agree. So several comments are saying that the prior company that did the repairs did not, they tried to reuse the old refrigerant, a number of things. I do agree. I think all of that is true. I don't think that they went back with virgin refrigerant, which led to a lot of the issues that they were having. Regardless, I do want to talk about a couple of things with that. So some of the one comment, well, actually no, there were a couple of comments. Everybody thought it was non-condensables, non-condensables, non-condensables. The condensables test that, and it's in the books that I've even read. If you can go read refrigeration books, and y'all are more than welcome to send me some material that contradicts this, like actual material that I can sit and read and verify. But when you get non-condensables in a system, you're not going to line up on your saturations properly. And so your saturation temperatures are going to be skewed from that refrigerant. So for example, if I had non-condensables in that 410A, I would have expected to see a lot higher saturations than the actual refrigerant saturation, right? So, if it was supposed to be 70 degrees, well, non-condensables would have given me 80 or 90 degrees of saturation. That's what I expected. We never got that. So there were people that were stating that, well, there's not, doing the test that I did and trying to compare saturation to find non-condensables has been something that myself and technicians have used for many, many, many years, and it's a valid test. And I don't quite understand why some individuals were not agreeing with that test. And I'm a bit confused. I'm just being completely open and honest at the moment. I don't understand what training you've had that has told you different than that. So I'm very intrigued, and I really want to know so that heck, if I've been doing it wrong for 10 years, I'd rather know now than another 10 years from now. So please send me something to validate your understanding of that so that I can then make a correction on my end if I need to. That being said, what really got us on there was that fractionation of the 410A, because 410A is a 50-50 blend of two refrigerants, and it is the glide is extremely small. It's what you consider a near azeotropic blend, right? Because the glide is so extremely small, even though what I think happened is we lost a lot of one of those two refrigerants. So instead of it being a 50-50, I think we had like a 25-75 mix in that system. And that was what led to the readings we were having. The problem with that is the saturation temperature was going to look almost exactly on point because their glide is so extremely tight. So that test wouldn't work on a refrigerant like that. Now, on a different refrigerant like 407C or 404A, or I think on other refrigerants that have a much broader glide, I think that test would have shown that fractionation a lot more broadly than the what we saw. So anyway, that was a really unique experience. I hadn't had one do it to that extent before. And that really, that one had me going. As you saw, if you go back and watch the video, if you hadn't seen it, it was I was racking my brain hard trying to figure out what was going on with this system. And the technician I had on site was an extremely experienced technician. Like he's got a very strong understanding of this trade and what happens. And both of us were really struggling to kind of put this one together. So anyway, we've been going for quite a while now. See, what's our time? Well, we're right at an hour, maybe. Yeah, right at an hour into it. So, if there are any final questions or thoughts or anything, now's a great time to kind of put them in. Otherwise, I'm going to start kind of closing this out. Family's down for a nap right now. I got a couple of things I'm going to try to get done in the meantime, and we're going to take us a fishing trip down to the pond this evening. So really looking forward to that. You can see actually here behind me, spent some time working on our poles, getting ready for it. But anyway, like I said, if you have any immediate questions or anything you want to jump into, now's a real good time to ask those. Otherwise, we're just like I said, we're gonna start winding this down. Um, and I'm curious, what's y'all's thoughts on like having a monthly live stream or something? I'm interested in that feedback. I don't have a tremendous amount of time in general, so it's it's hard for me to commit to a lot of things. That's also why my ability to respond to emails and comments and those things has really slacked. It just my life has a lot in it, and it's hard for me to do it all. So, um, I'm just curious, how much would y'all enjoy something like this on a more routine basis? I'm not going to do a week by week or something like, HVACR videos has an incredible live stream. I try to catch it when I can. HVAC Overtime has also a really good live stream and podcast. They're pretty stinking hilarious. I do enjoy them quite a bit. So I encourage you to check out their channels. But they do a weekly thing. It's not physically possible. So monthly basis, what are your thoughts? Let me know. Make a comment, send me an email. And thank you, Easy Heat, for the reminder. MTT guys, make the time for your family. That's a whole kind of sub phrase of this brand. I don't know what you call it. Anyway, make the time. And what I mean by that is make the time for your family, your kids, your spouse. We all are in this together. We all need to be together. I try to post some little short clips of, me and my daughter as often as I can, right? She loves having hands-on. It doesn't matter what we're doing. What she wants is to just be a part. And there's a lot of things that she can't do. She's only 2 years old. But in that time and just presenting that opportunity to her, I mean, she's figured out how to turn a ratchet. She's figured out how to work a screwdriver. She can go up to something and take a screw out. So what I'm saying is, don't underestimate your kids and your family. They just want to be a part of things with you. They just want to be with you, period. That's all it is. They just want some time. And we really need to be making sure that we're making that time. I don't have the time, never going to have the time. Nobody has it. The only way it happens is you have to physically make it. Okay? That's the whole point of the saying. Make the time. You have to make it. It's never going to be there. With that, I'll close out with that. I've said enough. Y'all listen to me talk long enough. It's really good. Once a month would be awesome. How do you check superheat with the new S-Man gauges? I don't know on the S-Mans. Don't use them. Not a huge fan of them. I've got my reasons. Not because they're a bad product. Just not my thing. Once a month would be awesome. 10-year-old daughter was soldering some stuff together. Yeah. No, that's awesome. I mean, kids have so much more ability than I think people give them credit for. It's really, it's a matter of how much time do you take to put into teaching them those things. Anyway, and I got flies everywhere. Oh, living on a farm, you get flies infestation all the time. Okay. Appreciate it, guys. Have a good one. MTT.